Hello everyone and welcome back to the MATLAB component of Bing 101. Today we're going to pick up where we left off on the previous segment and we're going to jump right into basic math operations. The operators are addition, subtraction, multiplication, division, power, and you have to specify the order of evaluation using parentheses. So similarly to how you would operate your TI-83 calculator, you can execute these commands using a combination of basic math operators and parentheses within MATLAB. So we could say, y equals 8 times 6 divided by 4 equals 12. MATLAB also has in a lot of built-in functions. You have to call these functions using parentheses and then pass a parameter to the function. So we would call sine, which is our function, and then pi over 2 would be the parameter we're passing. So for kind of reading through these examples, the first is sine of pi over 2, the second is the square root of 4, the third is log of 2, and then log base 10 of 0.23, then the last is sine of pi, and then arctangent of negative 0.8. And to see a list of the function, type help and then the name of the function. So for example, we can do, let's just do the square root of 4. Square root of 4 equals 2. Easy as that. There's also ways that you can transpose your vector. So the transpose operators turns a column vector into a row vector. The transpose operation is denoted by a single quotation. So if we do our vector A, let's say we already have A stored within our workspace, so type in A just to make sure it's still here. Then we could transpose A, and then we make a column vector into a row vector. To create a vector without typing in each different value, we can use a colon. So a colon is used to create an interval or pick out selected rows, columns, elements of vectors, matrices, and array. So I'll show you quickly how we do this. So if we go back into our command window and I type 1:5, we get a row vector going from 1 to 5. If we typed in 1:0.5 by 5, we get a row vector that's going from 1 to 5 and then increasing by 0.5. So it goes 1, 1.5, 2, 2.5, and so on. If you don't indicate this spacing step, as for the first example when it was just 1 to 5, the automatic setting is that it will increase each element within the array by 1. So shown here is an example when we are stepping from 0 to 0.5 at increments of 0.1. It's important to keep in mind the rules of vector algebra when applying basic mathematical manipulations of vector columns or vector rows. Addition, subtraction, and multiplication are element-wise, so sizes must match unless one is scalar. And by scalar, remember, it only has a magnitude. An example of a scalar would be something like temperature. So the following would give an error. So if you're trying to add a row vector or to a column vector, since you're doing this element-wise, there wouldn't be a lineup of each element. To add a row and a column vector, you're going to have to transpose either the row or the column so the sizes are compatible. To do element-wise operation, it's sometimes easier to use the dot product so sizes match up. So dot star denotes element-wise multiplication, dot slash denotes element size, element by element division, and dot asterisk or dot hashtag denotes element by element powers. So let's do an example of this in MATLAB. So say we have a let's do it, a array A equals 1, 2, 3, 4. So that's going to be a row vector, and we'll do b equals, let's do 5, 6, 7, 8. So that's a column. So we could say C equals A plus B. And here we'll get an error because our sizes of our vectors do not match up. But if we did D equals the transpose of B, now we're going to have two row vectors. So now if we were to say C equals A plus D, where D is the transpose of B, what we're going to get is a row vector where we're adding each element by element. So if we add 1 plus 5, we get 6. If we add 2 plus 6, we have 8. And if we add 3 plus 7, we get 10. And if we add 4 plus 8, we get 12. One important thing to note is that the size of our row vectors must match up. So for example, if A was 5 elements and B had 4 elements and we tried to add A plus B, we would get an error because the dimensions do not agree, because the number of elements in our two arrays is different. So for example, if we had B equals 1, 2, 3, 4, 5, and here we tried to add A plus B, we would get an error because the number of elements doesn't agree in this situation. And then we can do a example of element by element wise multiplication as well. So here it's the dot star denotes element by element wise multiplication. So let's go back to MATLAB. Let's clear all of our history. So we're starting from a clean workspace, and we'll say A equals 1, 2, 3, 4, and we'll say B equals 3 dot star A. And now what you see is we're multiplying every single element within vector A by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. We could also do this if we had, so now let's say C equals 1, 2, 3, 4. And now let's do C star dot A. Or sorry, I did that incorrectly. C dot star A. And now what's happening is that we're multiplying element by element wise the elements within our different vectors. So for the 1, it is looking at vector A, it's 1, the first element in that vector times the first element in vector C. So 1 times 1 is 1. Then it's 2 times 2 is 4, then 3 times 3 is 9, and then 4 times 4 is 16. So that's an example of how you would do multiplication, multiplying two different row vectors. So now moving forward, the last objective in today's lecture is to go over basic plotting. So basic plotting, plot xy, plots the y vector versus the x vector. It's used for 2D continuous data, for example, sine x of an ultrasound signal. So we can go ahead and show you some examples of basic plotting. So here I'm going to open up MATLAB. So sine of x, so if we have x equals, we'll plot our x axis is 0, stepping by 0.1 to 5, and then that would be our vector. And then we could say sine of, we could say y equals sine of x. Then we could go plot xy. And then what we get is a plot of the sinusoidal vector where we have defined our x-axis going from 0 to 5, and it's plotting a data point every 0.1. We could change the step size, or we could change the x-axis very easily. So if I go back into my window and I say x equals 0, now let's step by 2 and let's go up to 100. And then we'll say y equals sine of x. and then we'll do plot x comma y. And now you see that we're stepping all the way from 0 to 100, and we're plotting every 2 units. And why this looks funny, not like your typical sinusoidal wave, is that we're actually undersampling our data set because we're not sampling often enough. So let's look at the difference between plotting every 2 units on the x-axis versus plotting every 0.1. So now if we redefine it as y equals 0, plotting every 0.1 to 100, and y equals sine of x, what you're going to see now is a, so y equals sine of x, plot x comma y, is a much smoother signal. So making sure you pick the appropriate step size between which you're plotting is very important. Now let's go over the stem function. So the stem function is a very useful tool for plotting 2D discrete data. So basically, if you have x and y data, instead of having a linear curve fit to that data, at every discrete data point you're having a line plot. So let's go into MATLAB and see what this looks like. Okay, so first, you have to define what your x-axis is going to be using a vector. So or using an array. So x equals, we'll go from 0, we'll step up by 0.1, and we'll go all the way to 10. And then we'll say y equals sine of x. And then we'll plot the stem, so STEM of x, which is the x-axis, and then y. And what you get is a function that's going from 0 to 10. The increment is every 0.1. So every 0.1 we're having a data point, and then it's plotting the sinusoidal function. So very helpful in a lot of applications. Now let's go over the function subplot. So subplots is a really helpful function which enables us to look at more than one graph in the same window. So the function that we'll use to call subplots is subplot, where in parentheses we will define how many plots we want to view at one time. So let's go over to MATLAB and we can look at this. Okay, so within MATLAB, let's clear everything, clean up the window, and we'll say our x-axis again, let's go from x equals 0, step by 0.1, and we'll go up to 6. And then we'll say y equals sine of x, okay? And then let's say z equals cosine of x. And now if we wanted to plot both y and z in the same window, what we would use is the subplot, so subplot, and we want to look at 2 different graphs simultaneously, and the first graph of 2, so we'll call it as column 1, graph 1, so 2, 1, 1. Then we'll do a comma, we're going to plot x versus y, okay? And then we're going to do a subplot. Within that subplot, we're going to say we want to look at z as well. So it's going to be subplot 2, 1, 2. So it's going to be the second graph, and we're going to plot z, y. And then if we look at our figure, we have 2 different graphs. But the reason it looks funny is I didn't plot the cosine of y. I plotted z, y. So let's clean that up. So subplot z, x, and it should be what we were expecting. Nope, I messed up again, so sorry about that, guys. It's x, z, because you always put the x-axis in first, and we should get a graph that's on the top, which is x versus y, where y is the sine of x, and then the graph on the bottom is the cosine of x, so that's going to be the z variable. So this is how you plot more than one graph in the same window using the subplot function. So that's all I have for this first lecture on MATLAB. I hope this was a good introduction. I encourage you to play with these tools, so play with row and column vector multiplication, addition, subtraction, as well as play with how you would plot different functions using the plot function, using the stem function, as well as using the subplot. Thank you so much. Bye.